Let's continue with related rates. In the previous video, we saw a problem where we had an equation that was relating some variables, right? The coordinates of a point that is traveling following a curve, okay? In the next problem, this example we are going to do, we will have to figure out that relation. Okay, in this case, the situation we are given is the following. So we have a rectangle whose length is increasing at a rate of 3 centimeters per second. Okay, so here we have the rectangle and we have the length that is increasing. Okay, and it also says that the width is decreasing at a rate of negative 2 centimeters per second. So what is the rate of change in the area when the length is 5 centimeters and the width is 4 centimeters? Okay, here the question could be actually saying, is the rectangle disappearing or is it somehow increasing the area? What is the tendency? That's what we want to know. Okay, so when we have a problem like this, the first thing we need to do in order to start working is to decide what are the important variables. So here clearly we have the length and we have the width. And with that we need to work on the area. So first thing to do is to give names. To the quantities that are important. Okay, give names to important quantities. So let's make it easy. L for the length, W for the width. You can call them X and Y if you want. I just like to make it this way so that there is no confusion. And then A is going to be the area. Okay, so I have the length and the width. The length is increasing at the rate of 3 centimeters per second, and the width is decreasing at negative 2 centimeters per second. Okay, so that's the information we have. So this would be a step 1. Let's move it over here. There we go. Then step 2 will be find a relation among the variables. Again, this is the step that we, in the previous examples, we were already given. Okay, we were already given both the variables and the relation among them. In this case, we need to figure out, but it's easy because we want an area, right? So the area of a rectangle is the length times the width. Okay, so that is the relation we are looking for. Now, notice here, L and W are functions of time. They are changing in time, right? But then the area too. So in this equation, everything depends on the time. So we can actually write it if we want. A of t equals L of t, W of t. Okay. But now, what are we asked to find? So we are asked to find the rate of change in the area. So what is the rate of change in the area? It's dA dt, and this is what we need to find. Okay. So in this case, the equation is very easy. It's just a product of the two variables, but in general, it may be more complicated and we may need to use implicit differentiation. Okay. So this is the L dt times W plus L dW dt. Okay. And here, now this is the relation between the quantities and the derivatives. And now this would be a step 3. Okay, the implicit derivation. And step 4 would be to write down what we have and what we don't. Okay, so known and unknown values. Okay, so let me copy paste and let's see what we have and what we don't. All right, so the width, we have it, right? It was, yeah, it said that the length is 5 centimeters and the width is 4 centimeters. So length is 5 centimeters and the width is 4 centimeters. And then of the two rates, okay, we know that the width is decreasing at -2 centimeters per second and that the length is increasing at 3 centimeters per second. So actually this is very straightforward because we have all the information here. So we have 3 times 4 makes 12 centimeters square per second, okay, because it's a change in area, minus 10 centimeters square per second. So overall is 2 centimeters square per second. So this is saying that at that particular time, when the width is 4 and the length is 5, the tendency is to keep growing. Okay, it will be increasing the area of the rectangle, because we could be interested in knowing if it will collapse or not, for example.